Welcome to the next lesson in this chapter about module communication, and this is going to be a short but very impactful lesson where I'm going to introduce you to the concept of duplicating your data between your modules. We talked about this in some of the previous lessons, but I think it's worth repeating again, and this is the fact that the user entity in the users module can also be represented as a customer in the ticketing module, as well as an attendee in the attendance module. And inside of a modular monolith, and in general, when working with microservices, it's a good strategy to have your modules or services own the data that they require to provide the necessary functionality. So what I want to do in this lesson is to duplicate the user's data between the users and the ticketing module. We're going to have a users table in the users module and a customers table in the ticketing module. And you will see how this is going to simplify our ticketing module and also remove the dependence on the users module because we will no longer need to call the public API of that module. Go ahead and grab the updated source code from this video, and I'm going to walk you through what are some of the changes that I made that are going to make this lesson a bit more easier to follow. In the domain of the ticketing module, I added a customer entity. This is going to store the same information as the user entity in the users module. We just don't need to raise any domain events because this entity is created from an external source. In other words, the source of truth for the customer entity is actually inside of the users module. However, you can think of this as two bounded contexts, the users module and the ticketing module being the bounded contexts, representing the same physical entity with two different concepts in the domain. I also have a repository that we can use to fetch the customer. It's implemented in the infrastructure layer. And inside of the application layer, I have a few use cases for creating a customer by sending a create customer command. And we can also get a customer by the ID, as well as update a customer by sending the respective command. An additional thing I introduced is the public API project for the ticketing module. And you can see I define a ticketing API interface. And this interface has one method inside called createCustomerAsync. If we take a look at the implementation of this method, all it's going to do is send a createCustomer command. And this is how I'm going to implement duplicating data between our users module and the ticketing module. The only question that remains is how are we going to call the ticketing API? So let's use the synchronous communication approach and make an update to our users module. In the application layer, where the register customer use case is, I'm going to add a reference to the ticketing public API. And inside of the register user command handler, I'm going to add a reference to the ticketing API. So let me go ahead and introduce that as a dependency. So ticketing API. And then after creating the customer and saving it in the database, we can call the ticketing API and invoke the createCustomerAsync method. I can pass in the required fields from my user entity. So let's pass in the ID, the email, the first name, the last name, and the cancellation token. And this is going to send the respective command in the ticketing module when we successfully register a customer. This is also going to duplicate the data inside of the ticketing module so that we can simplify the implementation in that module. Here's what I mean by this. Now, if we take a look at the add item to cart use case, we can get rid of the call to the users API and instead use the iCustomer repository. I'm going to leave the call to the events API in place for now, and let's call the customer repository and get back a customer instance. Nothing else changes inside of our use case. However, now we are no longer calling another module to fetch the data because we have a customer entity locally. And let me show you how all of this works. I'm going to send a post request to register a new user inside of our system. So if I hit send, we're going to land on the breakpoint in the users module in the register user command handler. So let's go step by step through the command handler. And at this point, we have inserted the customer into the database. You can also see the SQL query in the output window that was written by EF Core. And at this point, if I take a look at the database, I would see the user inside. Now let's go into the ticketing API method, which is going to send a create customer command. This is going to be handled by the create customer command handler, and this will in turn insert a new record into the customers table in the ticketing module. So now we have our data duplicated between two modules, and I'm going to press continue here. And now let's use our newly created users identifier to try to add a new item to the cart. So I will go to my cart methods, and I'm going to replace the customer ID with the one of the newly created customer. Now, if I send this request, we're going to hit the breakpoint inside of the add item to cart handler. And this time, instead of calling the users API, I'm calling the customer repository. This is querying from the local database, which is the ticketing schema, using the ticketing database context. So we aren't making any calls to a public API of other modules, at least to fetch the customer, because we have that data duplicated from the users module. For the ticket type, unfortunately, we have to reach out to the events API, but we could solve this in a similar fashion, and you can see that we successfully managed to add the item to the cart. Now I want to discuss the pros and cons of this approach and how we could make a slight improvement. An obvious downside to this implementation is a significant increase in complexity of the register user command handler. We are no longer just writing something to the database of the users module or the respective schema, but we are also trying to write something into the schema of the ticketing module. In our case, this won't be too bad because we are still using the same database under the hood, but if these were different databases, we would be talking about a distributed transaction. And the question then arises, what happens if we manage to save this in the database? In other words, storing the user completes, but we fail to duplicate the data in the ticketing module. There are a few ways how you could approach compensating for this failure, but the improvement that I want to make is to remove the coupling between the register user command handler and calling the ticketing API. So here's how we are going to do this. In the register user use case, I'm going to add a new class. This is going to be the user registered domain event handler. This will be an internal and sealed type, and we're going to implement the iDomain event handler interface, and let's specify the user registered domain event. So this is going to be triggered after we have completed our call to save changes async in this use case. And what I'm going to do is just call the ticketing API from my domain event handler. So let's go ahead and do that. Obviously, I'm missing some information, but we are going to fix this slowly. For now, let's remove the dependency on the ticketing API from my use case and just revert it to its old state. So now let's focus on the user registered domain event handler. This will need the iTicketing API dependency, so let's inject it. And then we need to fix the call to create customer async. And we should be able to grab most of the required data from our domain event. So here is the user ID. However, if I try to fetch the other values, you will see that they are missing. So the simplest way to solve this is to send another query inside of this domain event handler. So I will say await sender, and we're going to call the send method and issue a new get user query. So from the notification, I can pass in the user identifier, and then we're going to grab the result of this query. If this is a failure result for some reason, let's throw an evently exception. And this would be a good opportunity to use exceptions because we really don't know how to recover from this failure inside of a domain event handler, because this is something that is triggered asynchronously outside of the normal application flow. So let's specify name of get user query as the request that failed, and I will specify the error from my result object. Otherwise, I should be able to use the result value to grab the ID of the user as well as the email, and then the first name and also the last name. So with this implementation, we are decoupled from the register user command handler, and we are duplicating the data in the ticketing module through our domain event handler, which is running after we have already persisted the changes inside of the database. Now, I did mention that how we publish the domain event handlers is less reliable, and we're going to solve this with the outbox pattern later on. But what I do want to comment on is that this is starting to look more and more like the event-driven approach that I prefer using. But keep in mind that even though we are using a domain event handler, we are still doing synchronous communication between our two modules, the users and the ticketing module. And we can slowly wrap up this lesson about duplicating data between modules. The price that we have to pay, other than duplicating data and increasing storage costs, is having a reliable way of how we can copy the data from one module to the other without introducing too much coupling and without creating a distributed transaction. I think the approach with calling the public API of the ticketing module from a domain event handler is a step in the right direction, but I'm going to show you how I prefer to do it in the next lesson, where we are going to talk about asynchronous communication between modules using messaging.